Today is 2025, 4th of January, proof elementary study. Today's problem was given two distinct real number, which is S is bigger than R, and consider all the variations with the form of K over N. We should find rational between with the form of. We should find the rational with this form between R and S. This was the problem. And there was hint, which was choose a number large N, which is natural number, which is bigger than 1 over S minus R. I will introduce all the process how we solve this problem. First, we can make this kind of inequality, which is R over N over K over N is bigger than R and smaller than S. Then we can split it in two steps, which is K over N is bigger than R. Then let's go first. The first thinking that we can do is we can just write K depend on R as K equals to R plus 1 and maybe N equals to 1. Then K is bigger than R. We can prove this. But actually there is counterexample, which is if R is irrational number, then K is irrational number. We should find rational in between R and S. Then we can think about how can we make rational number from irrational number. Think of pi. If we say pi and we want to get rational number, how can we get rational number? The first thought what I had was think about pi plus 2, then in between there will be some rational number, but I can't find specific rational number. How can I find specific rational number? We can use Gauss function, which is discard below point, discard this point, and just remains only natural number point. So we can get natural number. By using this, we can try it again. As we can set K equals to Gauss number of R plus 1. Then this is a specific example, we can get natural number. And also, to make N over K is bigger than R, we can, because there's also N here, we can make K from as N multiply K. This is kind of K prime, actually. So if there's no counterexample, we can go to next step. If we prove this one, then proof is finished. When we need to prove K over N is smaller than N, it was kind of difficult because S is same as R plus S minus R. And by using the hint, we can make this kind of formula. And this is N R plus 1. And which means we should make K over N smaller than this one. How can we make this one smaller than NR plus 1 over N? If we use K equals to N multiply R plus 1 Gauss function, then I'm not sure it is bigger or small. So we will change the form as this. Then this just make Gauss function on only this area and just +1, then this is explicitly smaller than this. Then we will check it again to this one. So we prove this one, and we will go this one again because we changed the format. If we look the format again, then this is bigger than R. So we can say we successfully prove. If we make form as Gauss function nr plus 1 over n can make rational number in between R and S. This will be very short number of proof if you find the proof. But actually, when you make a proof in a real time, you should think about a very simple format first. Just think about K depends on R plus 1. This is the simple format, but you should also think about counterexample. If R is irrational number, then you can't make irrational. So that's why we think about Gauss function. And after think about Gauss function, if we go successfully past the first step, so we went to next step. But there was also a problem. If we just use first format, we found it. We are not sure to make numbers smaller than this. So we changed the format, and then we changed the format. So we successfully finished this one, but we should check the first process again. And if we successfully process first and second step, then because we already make equivalent this and this as this one, so we can finish the proof. So you should think of always the simplest way and the counterexample and the number of cases that you can consider. Maybe we can also consider this format depends on R. Maybe we can change this format to depends on S. We can try it. But right now we successfully prove it. I will finish it, and maybe we can try it next time. The answer format depends on S. Thank you very much.